All right, next topic. So going from very low-level virtual machines and so on to the other end of the spectrum of how to do UI development in Rust in a way that it's actually quite nice and productive. So I'm going to be talking about Dioxus, a relatively new UI framework built especially for Rust by a relatively small team, mostly based in US, but they also have members elsewhere in the world. So a brief agenda, what this presentation is going to be about. So I'm just a user of Dioxus, so I'm not involved in any way of the core development and so on, but I've been involved with the project for about 1 year, using it for my own projects and giving a lot of feedback.
Arvoisa yleisö.
Go Tappara.
Erän alkuun 2 minuuttia.
So let's wait for 2 minutes. I kind of predicted that this was going to happen. All right, so first I'll cover what is this Dioxus thing, because probably most of you don't know about it, especially if you've been mostly interested in the kind of low-level Rust stuff. Then about why to write apps in general in Rust, especially apps in the user interface space. Then going through the Dioxus basics, just to give you an understanding of what it is and how it works. Then I have a short cross-platform demonstration here. Then go into a bit more details, just to get you more idea of why I chose, for example, Dioxus for my own projects. And then talking a bit about the future of the Dioxus, because it's still a relatively new project. A lot of things can go into all kinds of directions depending on the choices made. But let's start about what is this thing called Dioxus. So at least it's a good addition to that list of whether it's a Pokemon or a software framework. So easy mistake to make there. So it's an UI framework for app development in Rust. And the main thesis is that it's cross-platform. Just like Rust is cross-platform, it's designed to be cross-platform, that it has first-class support for all these, let's say, relevant platforms that you can build for web, for desktop, Linux, Windows, Mac OS, and also for mobile, iOS, and Android. There's also a bit of support for even terminal UIs, but that's kind of a sidetrack. And the main idea is that there's really like one code base, and you can compile it to these different targets. And it's based on, coming later on that topic, on how it makes this happen. And it's also very high performance, because it's Rust. We all know that it's fast. It compiles natively to all these platforms, including iOS and Android. So there's no like JavaScript kind of emulation layer or any kind of virtual machine running, except maybe on web, which is the WASM part. But I would actually call WASM, it's more native on web than JavaScript. It's just a fact that the browsers are built currently in a way that you have to go through the JavaScript layer to access any of the primitives, but it probably could be done in a more native way. You get much smaller memory footprint than other systems, and also the bundle sizes, even for web, are quite small. And it provides this high-performance full stack, so it's not only the client, but also on the server side. And from the developer experience, it's very familiar if you've been writing any kind of, let's say, JavaScript, TypeScript-based frameworks, React, Solid.js. It's using very similar principles. When you read Dioxus code, you can kind of understand what's going on if you come from that background. So it's a declarative system, not an immediate user interface system. And the tooling is very powerful, but it keeps things simple, so you can really get stuff done without a lot of boilerplate and so on. And it's type-safe Rust code, so you can just write your code and be quite certain to trust that it works as expected. And what's really interesting is this hot reloading system in Dioxus, because when you do user interface development, there's typically a lot of iterative things that you want to do. And in, let's say, traditional Rust programming, you need to recompile the whole thing, and it takes a long time. And this is a very important factor on all kinds of user interface frameworks, that you can get this iterative development very fast. So then why would you do this in Rust? Why not just use JavaScript or even Scala, like I used to do 8 years ago? Doing kind of similar things back then in Scala and Scala.js. Well, let's look at the alternatives. So these are kind of the four big ones for doing cross-platform development. React is, of course, the most well-known. React Native, based on JavaScript, so kind of runs everywhere based on that. But again, it's not really portable, because if you do web stuff, then React has a certain, let's say, set of components that you use on web based on HTML, but then React Native on mobile is actually using the native components, so you're not writing HTML style at all. So you kind of have the same framework, but you lose a lot of the compatibility. Then Flutter, which has been built kind of mobile first, so it's really good for doing iOS, Android apps. You can also do desktop apps. It's pretty okay there, but their story for web is pretty bad at the moment. It's getting better, but right now it's kind of a odd way of doing web applications. It's more like doing a canvas application inside the browser instead of a real web application. Then Kotlin, which is kind of the native Android stuff these days, they have this multi-platform framework as well. It's very kind of early development for many platforms at the moment, but they also are mostly focused on the kind of the logic of the application is in Kotlin, but then the user interface stuff is mostly, again, platform specific. Ionic is kind of the similar situation as with React, but it doesn't have the kind of native feature like React that it's always based on HTML. But of course, when you go to Rust, you get this great language. I mean, nobody likes JavaScript or TypeScript, or do they? Maybe somebody does, but at least Rust is kind of universally really a loved programming language by many people as soon as you get over the first borrow checker and other nasty things. Sure. You mean Dioxus specifically, or in general building Rust applications for web? No. Yeah, so basically all of the browser APIs are accessible from the code. So there is this, which is not really part of Dioxus, but this WebSys crate that exposes all of those things to the WASM part of the application. So you can build service workers even in Rust and access all the APIs just as you would in a JavaScript or TypeScript application.
So basically it uses WebSys and GSS under the root.
Yeah, so it's kind of a FFI, an interface between the WebAssembly and the underlying browser exposed JS APIs. Good. So you get type safety, memory safety, very solid coding principles. It's not like a mess that was created in 10 days, 25, 30 years ago, but it's really gives you a very solid base for developing applications. And there's a lot of libraries nowadays for Rust. And surprisingly, many of them also compiled on WASM, which is kind of limited because it's not really an operating system. So all those libraries that do operating system specific stuff, either they don't support WASM or they have a subset behind features that you need to enable features to, or limit features so that you can access the subset that actually works for WASM. A good example is Tokio, which is the async framework. The full Tokio doesn't work on WASM, but a subset does, so you can use it for async stuff as well. And it's natively cross-platform because, as we all know, you can compile Rust to almost anything that has a microprocessor these days, and it's native, very memory efficient, and the performance is second to none. Maybe you can get a bit more performance with C, but not any meaningful way. And also you get this Fullstack, which is, I would say the Fullstack is a very strong driver for TypeScript and JavaScript, that you can have the same kind of code base on the client and then on the server side. So you don't need to work with two different code bases. But with Rust, you can achieve the same thing. And the way the Dioxus is actually built, you can even run the same code on client and server, which enables things like server-side rendering, so which I will revisit a bit later. And also you get much better performance than on the server side, which is meaningful if you are building anything real, because it's not JavaScript or Python, which is always slow and takes a lot of memory. So you can really do a lot more with less resources when you use Rust also on the server side. All right, then let's go into some of the basics. So like I said, it's a declarative UI system, very much like React. So you basically write code that describes what the UI should be. So this is a simple example. If you've done any HTML, you can immediately see what it does. So you don't need to be explained that this does this and this does that. So it's very familiar syntax. It doesn't have that JSX style that looks like HTML. This is kind of a more of a Rust style syntax. There is also another library called Leptos, which is a bit more like HTML, that uses those angle brackets, but at least I don't like that kind of styling. And as you can see, there is this RSX macro that does all the magic, that you can do these kind of things that are not exactly Rust within the macro, so that it can then generate actual code from there, and you get this nicer syntax that it doesn't need to be fully Rust, but you can get these shortcuts by having this, let's say, very complex macro. And just like in React, the components are just functions. Yes.
Okay, I have a mic here, and this is also info for others that if you want to ask questions, there is now a mic available.
For the last presentation, now the mic is in the room.
Yes. So actually, I had a real question, which is that, or it's not a question, but rather, can I tell about the conversation we had online like 2 weeks ago about this?
Sure.
So I actually tried out Dioxus randomly for some random purpose, like about 3 weeks ago, and like when I wrote some of these blocks the first time, like I was following this tutorial, I was actually like super amazed how this macro works. Like when you edit something, like usually when you do user interfaces in Rust and when you compile it, it will take some time, upwards from 10 seconds if you're using some big libraries. So that's terrible. That's a terrible experience. But with this framework, you've got this RSX macro, and I wanted so I want to try another color, like change that gray into a green or something, and like see how it looks like. And you change it to green, you press Control S, and the web page that renders this application just almost instantly updates, and there's no Rust compilation going on. And then you're like, what actually is happening? I am writing this. I have this .rs file. I'm writing some Rust, and I edit these colors, and they immediately update on the other screen. So there's like someone is bypassing my compiler and doing some serious magic here, right? Like, what is this? Yeah, like this person leaves with the other. I shout like go look at this. This is what's going on here. This is crazy. So yeah, that's what the test was. And then I go to Codeclinica, and I'm like an online server. Like please someone explain to me what's wrong with this framework. Like this is kind of cool. So that's then I guess from the follow up to that was that you offered to give this presentation here. So maybe that's related. So please. So that's my take on this cool macro.
Yeah, I think this is really the biggest selling point of Dioxus, is this system of hot reloading, which I will cover in the live demo shortly. That it really makes it totally different. That you can do the same style of development as you would in the JavaScript world. Although I have to say that now even in JavaScript world, it's getting quite slow. That when you have more complex systems, the kind of hot reloading is not so hot anymore. But yeah, so internally it's using this virtual DOM, just like React and many of these others. So it's reflecting that, okay, what changed? And then it goes and updates the actual DOM, because especially on the web, and it, kind of the same thing on other platforms as well, because it's using HTML and CSS. It's web rendered on all these platforms, whether it's a mobile, desktop, or web. So that's why you always also get the same results. But the way it works, if I just digress a bit into the internals as you address this topic, that it has this virtual DOM. This macro is not just converting this code into Rust, but it actually generates all kinds of templates that what is something that can change. Like in this example, this comment by can change, but this div otherwise cannot change in the sense that when the code is run, those things don't change. So it actually then caches those things also on the kind of JavaScript side, so that when it does update the DOM, it doesn't need to communicate that much over the WASM.js boundary, and it can be very, very efficient. But yeah, so from a user point of view, it's very, very simple to use and very easy to get started. And it has some of these nice things that you can do a for loop or an if expression within the RSX, and it works as you would expect. Again, something that's kind of missing on most of the JS frameworks, that you have to do some other things that are not really kind of native in the syntax. And then the state management also kind of follows the same principles as in, at least in solid.js. It's using these signals that you just define a signal, like count in this example, and then, well, you can ignore the use effect. It's not super relevant, but it just shows that when that signal changes, it automatically captures that, okay, what should be executed. And because the use effect closure is calling count, so it's using the signal, then whenever the count changes, this effect is rerun. And all of this happens automatically so that you don't need to manage the state manually. And then in a button press, you can just increase the count and then display the count, and just works very, very easily. It's based on this kind of hook mechanism. And this use signal is based on this kind of a Dioxus built-in hook mechanism, that this use effect is also using this hook mechanism. And there are several others kind of predefined hooks that use this same mechanism of following the changes and automatically propagating what's going on. And you can also pass these signals down as properties to other components, or even in this context, which is more like a global place for signals. Again, if you've done anything in React, you know about these things. If you haven't, maybe they are a bit new, but it's the bleeding edge of UI development in this fashion. And one really interesting fact is that, of course, your application is not only code, but there are all kinds of assets. Especially when it comes to HTML, you need to have CSS, images, fonts, all kinds of stuff. And in a traditional, let's say, web application development, these are kind of a side path, that they are not part of your application, but there is a different processing step that then collects and processes these assets, and you have to declare them separately, or they just go through all your files and try to do these things. But in Dioxus, it's done differently, that there is this asset macro where you basically define that, hey, I want to use this asset, and you just use the file name as it is in your project folder. But then internally, the system kind of tags this into the binary, that when you compile, it goes into the dependencies, and then at the linking phase, it collects all these assets that have been mentioned in different crates, in different parts of your source code. It all gets collected and processed, optimized, and so on, into the final bundle, or into the web folder assets, or whatever your target is. And again, this same mechanism works exactly the same for all these platforms. So if you are doing desktop, mobile, or web, it's always the same mechanism. And you don't need to worry about all this asset management. And you don't ever get any extra assets, because if you are not using it, it doesn't get linked in. So even if you have all those files in there, they are not brought into your final application if you are not actually referencing them in your code. And this is something that was kind of added in the latest version of Dioxus to make it really, really very convenient and safe as well. And finally, there is this tool called Dioxus CLI tool, which is a command line tool for building, bundling, and then also running applications in development mode. Again, I'll show it in the live demo shortly. And it provides this kind of full stack development. As you can see, there is both app and server, which are being compiled separately at the same time in parallel. So when you make changes, it always compiles the app and server, because like I said, the server code quite often contains same stuff as the application code. And it does this automatically, and you have some commands to ask for a rebuild and so on. And this also handles the hot reloading that Hexa was mentioning, that this is where the kind of magic happens, that this is the one part that detects these changes and then does that minimal compilation and then sends the changes to the client that, hey, now this and this has actually changed. So a lot of effort went into this tooling, and also it's the same tooling again for all platforms. No need to learn all these different things for different stuff. All right, then the fun part. Let's see if I can code something in this. Let's go back. So first, a bit about the setup. So I have this. So this is the application. This is all the code that's in the application at the moment. There is the main function, which is just launching the application. Again, of course, when you are doing a real application, this gets more complicated. But when you just want to get started, you can do it like this. So you just point out that, okay, the app is the root element of your application. And here we just use these assets that are defined here. That I can just say that, hey, href to this asset, and it will compile into the right kind of code. And then we have the typical hello world as usual. And I also have this Android emulator running here. So I have these two Dioxus CLIs running simultaneously. So one you can see here, this is for the web full stack. And then I have this second one over here, which is then building for Android. And these are currently both running at the same time. So let's take these into the. So let's change hello Tampere. And that's the time it takes to modify your code to some extent. Of course, you can't do everything, but you can do a lot of stuff. So let's add some styling there to make it look nicer. So you can imagine that when you are developing an UI, and this is the kind of time it takes to iterate on all these changes. So one thing I didn't mention yet is that I'm also using Tailwind CSS, which is a JavaScript. I think now the latest version actually written in Rust. It seems to be the trend in JavaScript world that all the tools are getting rewritten in Rust to make them actually fast. So it's just another program running here, watching the files. So whenever I introduce some new styles from the Tailwind, like this text3xl, it kind of recompiles the CSS file, including exactly these classes that I'm actually using here. So it makes it quite convenient. It's nothing to do really with Dioxus, but it's let's say a typical starting point at least for development. And you can also let's add some. I'm using cursor, so that's why everything happens kind of like tab, 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 and it's done because I did this once already, so it knows what I want to see. So I can do some changes like this, just to add some structure there. Again, I can add new elements. It's instant reload. No real compilation takes place quite yet. So let's add this header part here as well. Let's see if it remembers what I know. And the image. So for the image, I'm going to need to add an asset. Tampere logo. I don't have a Tampere logo. Where does it get that? I don't have that. I'll have to go and look at my cheat sheet. What was it? Header SVG. Now it knows what I want. That's AI for you. But now as I introduced new code, basically this asset definition, now it needs to recompile both of these code bases. So normally, of course, you wouldn't be running two different instances at the same time. And this is a Windows limitation because it generates a new executable with a new name, and the firewall is kind of picky on what's going on. But as you can see, this takes a lot longer to do this kind of real rebuild, especially when you are having two things running in parallel. So let's stop the Android one. I think I've proven my point already here on how it works, and focus on this one. So I just added an SVG, referenced it in an image, and it's there animated as SVGs can be. But this is now all static stuff. So let's ask the AI to do some stuff for us. It's nice, but it's not visible. So again, okay, I didn't define the count, so now I need to. And this needs to be a closure. So again, now it needs to do a kind of full recompilation. And well, this is a bit slow on Windows because I can't use the mold linker. On Linux, I can use mold, which then is much faster. So now I added some interactivity. So I defined this signal, which is now controlling the state. In the button, I'm just increasing the count by 1. And when I click it, it automatically then updates the paragraph that's referring to the count. What else did I have on my to-do list? Okay, so let's make it a bit more complex. So let's add this kind of list of links. So let links. So this is going to be a static list of links. Again, I'm going to want to spend too much of your time just copy pasting this instead. So I'm going to mouse. So going to define this structure that I'm going to be using as a parameter. So just an external link with a URL and some text. And then let's copy paste these links as well. Right, and now let's define a new component. So, yes. That's why I don't use Windows for development. So the component macro is something that changes this function in a way that it seems like you take just a parameter, but in reality the component macro does it in a way that you actually get this structure of properties, which allows then for tracking the changes and making the use of it here a bit more easier. So the way you call components is just like you do with HTML, that you just kind of call the component by giving it the properties, and the properties are named here. Here it's link. Expected. Okay, so the AI didn't know what this was doing. So you can't just put like a string directly into here. You have to put it inside this kind of a Is it still doing something? Rebuild. Yes. I hadn't used Windows for Dioxus development, so this was a bit nasty surprise that you always have to click OK. But no, okay, now we see these things here. And as you can see, it's very easy to read, easy to understand what's going on in the code. And maybe as a final exercise, let's use this Fullstack functionality as well. So this is now currently running purely on the client side. There is no interaction with the server besides just getting the HTML. But maybe we could actually at this point take a quick look at what is actually, when I reload this. So if you take a kind of a close look, so this is actually coming from the server now. So as you can see, the server has rendered this HTML. So it's not like your typical React application that you just get the scripts onto the client and then the client generates the DOM and so on. But the way Dioxus works with this server-side rendering is that the same code is being executed on the server side. So it generates the HTML on that side and then sends it to the browser, so it's immediately accessible, can be used for search engine optimization and so on. And I don't have to do anything. It's fully built in. I would say much better user experience than on any of the JavaScript-based frameworks that support the same thing. So just a quick side tour there.
What would a release look like? What would a release look like?
As in,
Dev tools. Like a release build.
as like in the size of the release, or
Yeah, the HTML is on everything.
yeah, I mean the size is very compact. Of course, the WASM is the biggest part, but it can be like 50, 100 kilos, so nothing spectacular there. Then the current HTML, of course, contains a lot of this development stuff there, all these scripts that allow, like when I do changes, it will track these things and so on. So in the end, when you do release, there's nothing else there besides what you put in your code yourself. And they have also, they used to be, I think it's now fixed, that there used to be a lot of, like half a dozen JS files that were small JS files that were loaded individually. Then I complained that, hey, this is not the way to do it. Now they are getting bundled together. All these, again, if you look at the file names, for example, in the network tab, so you can see that these are hashed names. So again, for caching purposes and so on, you get these optimized files, and they're compressed as well. So if the browser asks that, hey, I know Brotli, the server will give you the Brotli version of the, and all this again happening that you don't need to do any configuration. It's all happening automatically. Although there is the downside, which I've also been a bit critical, that it's a bit Sunday happy case framework, that they've been so focused on this easy developer experience that when you actually do some real stuff, then you encounter all kinds of things that, hey, I want to do this and that, but you made it too easy. I want to do it differently, and then you have to get a bit more involved. But even then, it's quite okay nowadays. But all right, so again, so server functions, let's do some additional copy pasting, because why? So this is the way you define. Again, these are all in the same file. As you can see, no separate files for server or client. But when I use this server definition here, it creates different implementations for client and server. So on the server side, what you are doing here is actually present, but then on the client side, this is being replaced by kind of a proxy, that when you call this function in your code, it actually then delegates it to the server, and when you get the response, the function returns. So that's why it's also an async function. And let's define this component. it just echoes whatever is going on. Thank you. And then add the echo. The downside of having this very new framework is that the AI tools don't really know what's going on, and they usually are not very helpful when developing Dioxus applications. Although there are efforts going on by the Dioxus core team of defining their own fine-tuned LLM for Dioxus. So that's something you can take a look at as well. All right, so now we have this echo thing here. And as you can see down there, it does these API calls. And again, this name of the function has been changed in a way that it's always guaranteed to be unique and so on. This is one thing, again, that when you are doing a real thing and you need API versioning and so on, you have to be a bit more involved. You can override these names and so on. You can override how the parameters are encoded and so on. So you can definitely extend this system, but again, it's very easy to get going and very, let's say, developer friendly.
We work the same way with WebSocket.
So this is not WebSocket. So again, if we look at what's going on under the hood, let's actually.
It's HTTP, but would WebSocket be a far fetched?
Well, WebSocket is not supported by this serve function system, I think. It's currently, so it does do this. How can I separate this? So when I do these things, it does for every key press there is a call to the server. But of course, normally you wouldn't do it this way, that you would send it to a server. Well, if you have a search field and you want to do stuff faster, then you can do. But again, if you look at what the code for this is, it's just an input that whenever the input changes, it will call this closure echo server with the value, and then it will set this response to the data that has been echoed. All right, but I think that's all for the live demo. And again, all of this would work on the Android or desktop the same way, except I've had some trouble getting these server functions running, at least under Windows. But there's some port conflicts or something that it doesn't work properly. But on the web, it works just fine. All right, so then the benefits, which are probably already covered quite well, but I think performance is, let's say it's surprisingly good, because you consider that you are running in WASM, which is kind of a different part of the browser, and it needs to communicate with the JavaScript part, doing all the DOM updates and so on. So these performance tests are very typical JavaScript framework tests that are DOM manipulation tests. So this is something where Dioxus should definitely be the underdog, because it has to do that extra step of going from WASM space into the JavaScript space to do these changes. But because of a lot of smart optimizations, it's actually doing on most tests better than React, and in all tests, let's say very well. That this is not going to be a problem for web development. Or of course, the same thing kind of happens on, I didn't really cover how it works on the more native platforms, but over there, they are using a web view, a web renderer, which is again a separate component, and it needs to communicate with that to update the DOM. So the kind of same mechanism is ongoing there.
I think they through WebView.
Yeah, there is this project ongoing that they would replace the web view with a kind of a more native renderer. Of Of course, it's not fully like 100% compatible with all the web standards yet, so that's a work that's ongoing, but it's looking pretty good. So that's again, it's going to be a good increase in performance on those platforms. And as you can see, the bundle sizes are quite small once you build for release mode. In the debug mode, it's a lot larger, but it's not like a problem really during development time. And the startup times. So one thing maybe worth mentioning on the backend side is that although you can't really currently easily compile the Dioxus backend to WASM, which would be something that you could then host on these edge networks. But you can do, of course, a lot of server-side stuff in Rust and then compile to WASM, and then you can deploy it to the Cloudflare or to the other networks that kind of support WASM. And you can reach like 30 microsecond latencies on those systems that the startup time is very small because some of them are actually compiling the WASM code to native code before even run it once, so it's like running against native stuff. Yes, but then you kind of lose some of the functionalities if you are not using. You can always compile the front end part as a kind of static. It's just a WASM file and an index HTML and then the assets. So that's all you need to deploy, and then it works with any backend you want. And also, I mean, Dioxus is built on top of Axum, so you get all the Axum benefits as well. So it's not like trying to do everything itself. It's just plugging into the Axum to provide some of these functionalities that are especially useful during development time, but also the server-side rendering and so on are there. So full stack, 100% Rust full stack development. You can run the same code as demonstrated. You can share the same data structures. Makes it very easy to build full stack applications. Like I said, one of the biggest benefits of the TypeScript, JavaScript ecosystem is that you can have the same code base on both sides, but then you have shitty code on both sides. So I don't know how good that is. And the server functions make it easy to get started with this REST API, but I would maybe argue that for a lot of use cases, you really then want to just go to define your own APIs and call them normally and so on, instead of relying on this server function system, which is okay, but again, when you need to start thinking about versioning your APIs and stuff like that, it gets a bit trickier. So the SSR is a big plus for many applications if you want to have any kind of search engine optimization or caching the whole thing, that you don't need to even go to the server because it's all already cached into Cloudflare or so on. But you can also do static site generation. For example, if you look at the Dioxus website, the documentation, it's all generated using Dioxus as a static website. And it has even support for this incremental static site generation, which means that if you have, let's say, 5 million products, it will generate those pages on demand, and it will store them on the file system, so that when somebody is asking for that same product information, it will be coming from there. So a lot of these kind of advanced stuff also on the server side, even though the focus is definitely on the client side. And yeah, the hot reload, as I demonstrated, is a really killer feature of this that makes it very, very nice to use and do this kind of iterative development that you are kind of used to when it comes to web development, at least. But like also it works the same on Android or iOS or desktop, so you get all these benefits. So even if you are not doing web development, maybe you have some use cases where you would need to, or you would like to have a desktop application for some of your Rust stuff. This is a very, very good way to do that. Again, works on all major platforms. And there is an interesting addition coming that they have already prototyped, that they will actually do this binary patching, in-place binary patching. So you can do changes outside of that RSX macro, and it will still do a hot reloading, that it will not do a full compilation, but it will just look at that what changed, and then it will apply those changes. So you don't lose the state of the application. The code is just being modified underneath. Then a few thoughts about the future of Dioxus. So I would say that in many things are already in good shape. So there is a core development team, solid funding, and all those things to do this work. I would say the architecture is good. The tooling is already in very good stage. Again, the developer experience in that sense is very good. Support for web and full stack is pretty good. I would say desktop is already quite good, but like you mentioned, there are still work ongoing on improving the rendering and those kind of things. And when it comes to these native applications, it's not just the web stuff that you want. That there are all kinds of things that you have to access the native platform for many things, and these are still very much work in progress, but already for many use cases, a very solid thing to use. 25,000 stars on GitHub, so it's pretty popular. Thousands of downloads of the library every day. Quite a lot of, let's say, well-known names using this for whatever internal stuff and so on. Not so many public examples yet out there. Then on the needs improvement side, documentation is far from perfect. It definitely improved quite a lot in this latest 0.6 version, but still, as usual, the core development team is more interested in writing fancy macros in Rust than writing helpful documentation for the rest of us. But it's getting better. But this also kind of reflects on the AI stuff, that the AI doesn't know how to do these things because there is not enough examples and documentation available. I would say it definitely needs a UI component library. So now it's more like a React than Flutter, because Flutter has this full built-in component library that you can just start building applications and they will look nice. With Dioxus, you start the way I started, that you have Hello World in the left top corner, and then you have to figure out how to make it look nice. And a UI component library would solve that. Of course, it's an optional thing. You don't have to use it and so on, but it would definitely help a lot of the developers to get going, especially since it's not like the JavaScript ecosystem that's full of these component libraries already out there that you can't just readily use in Dioxus. The mobile platforms are very early at the moment. Don't go publishing any applications built on Dioxus quite yet. But again, it looks pretty good. But I think there also the challenges are going to be the native integrations, not the rendering of the UI. And also the release process and stability leaves a bit to be desired, that quite often the releases come when they think that, yeah, now we did something nice, but then the documentation is not updated. Many of the examples are broken, some of the templates don't really work, so there is not really this kind of solid process that what do we need to do to say that now the release is ready. And this also leads to these then to stability issues. All right, but that's all I had for you today. So thank you. Any further questions?
Thanks, Otto. Great presentation. My question is about third-party libraries. You said that there isn't one right now for this. So was it that you cannot use any like JavaScript libraries with Dioxus?
Well, you can definitely use JavaScript libraries, but then the interface between always needs some work, because you have to go through this websys to call. I mean, you can call eval quite easily from Dioxus to do so. If the library is very isolated in a way that it just does its own thing and you need to call one function to update something, then it works nicely. But if you need to integrate it into the DOM and so on, then it gets more complicated, or if the API is more complicated. I think there are already efforts on bridging some libraries in a way that you define the interface on the Rust side, and then actual implementation is in JavaScript, because it doesn't make sense to re-implement everything in Rust. And also because it's using now, I mean, the point you made about the new renderer is that the new renderer is not going to be running JavaScript. So now you can still do like desktop apps that are running JavaScript in the web view, so you can use JavaScript stuff over there. But with the new renderer, you also lose that option. Then it's just HTML, CSS rendering, but not JavaScript. If I've understood correctly. You also had that.
Thanks.
I wanted to ask and wonder how flexible Dioxus is. Like, I can see that it's very opinionated about React syntax, and I'm sure some of us don't like even using React. So for an example, if I want to use, for me, if I'm developing in JavaScript, I like to use vanilla JavaScript because of its flexibility. I wonder if it's possible to use that in Dioxus, like use WebSys or GSS instead of the React syntax in there.
Well, definitely it's possible, but then you lose all the benefits of the RSX macro, as we discussed, that it's actually generated these templates, and the high performance is coming from the fact that it's generating these templates. So if you just kind of sidestep that and start updating the DOM more manually, you will just lose a lot of those convenience benefits and performance benefits as you go. This is something that comes up from time to time in their Discord as well, that people are like, hey, I want to do different things. But it's I mean, sure you can, but I would not advise doing it. Because of course, kind of the goal would be more like a Flutter experience, that you're not really doing HTML stuff, but you're just putting these components. And then the syntax is quite nice, that you have this hierarchy of components with properties, and that's it. And you just define it like that, and it's very, very convenient, very nice looking. The HTML stuff is now making it a bit messy, because you have all these HTML attributes and stuff like that.
I got two questions, but they are related, I guess. Rust is pretty picky when it comes to panicking. So if something goes wrong, then you get to panic. What would happen in this type of scenario?
Yeah.
Say that the server side.
Yeah, well, the server side is just normal server-side Rust code, so you don't want to panic ever there, because that will terminate the server. So you have to do the normal error management. But for example, here I actually introduced a point where an error can happen. So for example, here I'm calling unwrap on the response for the server, and that will panic on the client side if it doesn't get the response from the server.
Yeah, and what happens at that point?
Well, on the client side, I mean, you get into the logs that, hey, panic happened, but nothing else happened. Because the way the WASM thing works, that it's not like, well, I'm not sure, but I think that it doesn't terminate the application. It's just that it ends that event loop, and then it starts the event loop again, and it will continue from the next thing that happens. Because that's the way the web works, that there's this event loop that then calls your code. And if your code fails, well, that execution path failed, but then the next time an event happens, it's just fine again. But there is actually a recovery mechanism, so you can put like a question mark here. Because this, okay, maybe it doesn't. So, okay, maybe it doesn't work right there. But so this element is actually an alias to result. So you can return and render error from your component. So if something goes wrong, and then you can catch that error up in the component hierarchy. So you don't need to do error management on every level. You can just delegate the error management to whatever level you want to do it. And this was also a new change in the latest version.
And I think that is what you want to do on the server side as well. Yeah. Of course, because this is also running on the server side. It's not running because it's being executed only by the click event, and that click or that input event doesn't happen on the server side. But what you can do, like if you want to load, let's say these links were not here, but you would want to load those links from the server,
then you would use this use server future hook that will actually, on the client side, it will just call the server and then render the stuff. But on the server side, it stops and waits for the result because it needs to render the HTML. It cannot just skip it and send the result. So it works differently on server and client side. But this also makes it possible that when you do server-side rendering, you can call databases, render the results into the HTML, and it will work just as expected, and the same code still works the same on the client.
The follow-up question would be about testing, to integrate this in a CI for like change testing and stuff like that. How would that look like?
So there are methods for, so typically like two things that are at least mentioned in the documentation. One is what does the component produce? Like what kind of HTML does it produce? So that's something that you can run a test to render the component with these properties into HTML and then compare the results. That is it correct or not? So that's something you can do in a test. And then the other more complicated thing is how to test these state changes, these hooks, these signals, and so on. But for that, you have to refer to the documentation. I haven't done any testing yet.
Thank you very much.
All right, anything else?
Yeah, I have. So exactly, how difficult is it to deal with things like Bluetooth or like listening to network sockets on the client side?
I don't know. I haven't done. I've only done really web full stack development myself. So I did look into some of these things for the presentation, but I haven't done any real stuff. But there's quite a lot of examples. But I think that's one of the pain points currently. That how do these native interfaces really work? There is this SDK project, Dioxus SDK, that is addressing these issues, but I would say it's still quite early days on that.
Okay, thanks.
So they do try to also abstract that in a way that it would be the same kind of interface on different platforms, but
That's certainly a lot of work.
Yeah. I would say that there's still a lot of work for desktop and especially for the mobile to make the true development experience as good as it would be like in Flutter at the moment. And I mean, it's like 4 or 5 guys doing this, and it's not like the huge resources behind Google and Flutter and all these other things. Okay. But I think they've done an amazing job so far with the limited resources they have in a pretty small time frame as well.
That should be all the questions. So let's thank the presenter. I think it was great.
All right, thank you.